Aloha. Today is we're looking at tables and how the AP exam likes to use tables. They use like approximation and Riemann sums with our LRAM, RRAM, MRAM, trapezoidal rule. They throw some mean value theorem in there, sometimes some IVT in there, intermediate value theorem, some average value they throw in there. So that's what we're looking at, okay? And we're going to start out here in 2018. And as we do these, we want to see what the AP likes to do from year to year, because that's kind of what the better predictor is. And then they're also going to make, they're always going to mix things up. So we have to be aware of that also. But here we go. Here's an example of a table. Height of a tree. Okay, and they tell us that it's twice differentiable. And everybody every year says, why the heck are they telling me it's twice differentiable? Well, if it's differentiable, that means it is continuous, right? And we want to pay attention to those things as we do some of these problems, okay? But they give me a table. It's twice differentiable. This is h of t, so it's not a rate, which is interesting. It's just meters and years. Okay, so if I wanted to graph it, I could graph it. But part A says, use the data in the table to find h prime of 6, the derivative. Now remember, derivative means rate. Okay, rate means slope. Okay, so at t equals 6. Well, there's no 6. Well, if there's no 6, wouldn't it make sense, class, to maybe do an average rate of change, right? That's what that derivative means, right? It means either instantaneous rate of change or average rate of change. Here I could find the average rate of change between 7 and 5. And if I do that, yes, that is going to give me a derivative. So it'd be 11 minus 6 all over 2. What would that be? 5 over 2. So that would be the average rate of change, which would be 5 over 2 or h prime of 6. Now they ask, using correct units, interpret the meaning. Now, let's just be smart here. The top is in meters, right? The bottom is in years. So right there, you guys, you got units. So it'd be 5 over 2 meters per year. Now, the other thing the AP wants you to pay special attention to is that this is the rate. They want you to know that derivative, that little tick mark I means rate. Okay, so it's the rate that those trees, or that the height of that tree is growing, okay, at t equals 6, at that 6th year. And it would be 5 over t. So they like to hear the word rate. They like to hear that it's changing. Okay, so at t equals 6, it's changing at 5 over 2. And they want to hear you say meters per year. Okay, all right, and that's it. What would that be worth? I'm looking over here. That'd be worth 2 points. Okay, you guys? Okay, so make sure when I'm giving these explanations, you write them out. All right, explain why there must be at least one t in between 2 and 10, where h prime of t equals 2. I don't know about you, but when I look at that, and when they say at least one t, and then they give me a instantaneous, an I rock, that this is a MVT, dude. And then we got to go back. What did Mr. Tanaka say? Well, he said, whenever I do an MVT and whenever I explain this stuff, man, there's 2 things in the hypothesis that got to be true. Well, what are they? Do you remember? Well, it's got to be continuous on the closed and differentiable on the open. Remember that? And you have to state this. This is the explain why there must be one. So you should write it down right now. Since h of t is continuous on the closed. Now, how do you know it's continuous? Well, because it's differentiable, and you should say that. So since h of t is continuous on the closed and differentiable on the open, because it says it's a twice differentiable function. Okay, we know that. We know that. All right. And then there must be at least one t. And you don't have to say there must be at least one t such that, but you need to know what the mean value theorem formula is. And remember, it is, and I'm going to write the general one. It's f of b minus f of a all over a, b minus a. Remember, they just have to be in the right order, equals f prime of c. Remember, that's the formula. And guess what? They give you the IROC. So all you have to do for this problem is find the average rate of change. All right, so between 2 and 10, is there ever a case where the average rate of change is 2? Right? Because it's got to equal 2. The AROC has to equal the IROC. And it happens, boom, right there. So you would show that h of 6, h of 5 minus h of 3 over 5 minus 3. And what would that be? That would be 6 minus 2. So it'd be 4 over 2 which is 2. Check. Spling. 2 bonus points for doing that. But remember, specifically says here that you say in your conclusion that you're using the mean value theorem. Okay, so and I guess I didn't do the best job of explaining the ending of that, but I'll say it right now again. Since H is continuous on the closed and differentiable on the open, the MBT guarantees a value, okay, between 2 and 10 such that H prime of T is equal to, okay, let's keep rolling. All right, let's go with C right now. Okay, use the trapezoidal sum. So I better remember what the formula is for the area of a trapezoid. Okay, right there. In the table to approximate the average height of the tree. Whew, a lot into this. Not only do I need to know the trapezoidal rule, okay, or how to find the trapezoid approximation, okay, I also need to find the average height. Average height, ding, 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 should immediately in your head say, oh, this is the integral from 2 to 10 of the height of the tree divided by the interval. That's all you got to do. And then the bottom is 8, donezo, and so all you got to do is the top. And believe it or not, to do at the top, they told you exactly how to do the top. Remember, this means the area under the curve. How are you going to find the area under the curve? Using a trapezoidal sum. Boom, that guy right there. So I'll write out all this work. I know I'm not going to have a lot of space here, but I'm going to have to split this up. And it says use 4 subintervals. So boom, 2, 3, 4. Works out beautifully. So from 2 to 3, it'd be 1/2. The height would be 1 because it's from 2 to 3. And my bases would be 1.5 plus 2. And I just have to do this. I apologize, you guys. Remember, this is just the integral part I'm doing here, but I'm going to have to come down here. Plus, the next one is 1/2. Now it's from, let me erase this so I can have you guys follow me. Now, the first one was from 2 to 3. The next one is from 3 to 5. That's a height of 2. And my bases are just those guys, 2 plus 6. Okay, plus 1/2. Okay, what's the next one? 5 to 7. It's a height of 2. What are the bases? 6 and 11. And then I've got one more to go, which would be 1/2. This time it is 3. Easy to make that mistake. And then 11 and 15. Now, if you do all of that work correctly, for the integral part, it says I get an answer of 65.75. Make sure you check it. It's non-calculator. So it is a lot of work you got to do on this one and then divide it by 8. Now, believe it or not, if you left your answer like that on the AP exam, they would give you full credit. All right, that one's just worth 2 points. We got one last one to go, and boy, do I remember in 2018 did my students struggle with this. Why? Because it's a long read, but you got to be careful of a lot of things. The height of the tree in meters can also be modeled. So it's also modeled by this fancy equation, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the tree is increasing. Remember, I taught you guys all the time in class to write down anytime we deal with rates, to write down off to the side the information it gives you. So what do we have? We got when g of x equals 50, okay, the diameter of the base of the tree is increasing. So the diameter, and diameter is what x it says. So dx dt equals 0.03. Okay, according to this model, what is the rate of the change of the height of the tree with respect to time? Oh my gosh, so I've got to do dg dt equals question mark. Holy moly, let's go. Give me them toes. All right, there's a lot I got to do right here. Okay, the first thing is I got to find the derivative of g, but the derivative of g with respect to time, with respect to t. This really messed up my students. So let's find the derivative of this with respect to t. It's got x's in it. All right, well, that's a quotient rule. Okay, so let's go dg, and it's really of x, over dt. Okay, so this would be the low times the derivative of the high. And the derivative of 100x would be 100 dx dt minus the high, which is 100x, times the derivative of the low. And the derivative of the low would be 1 plus x. That'd just be 1. but implicitly dx dt. All over no. 1 plus x quantity squared. How about that? What do I get for that? Oh, do you get 2 points just for doing that? Sweet. You get 2 points, class, just for doing that piece. Okay, so here we go. I'm going to pause this. All right, class, I had to pause that for quite a second because they did it a kind of like way tougher on the AP exam. But this would be equal to, now I just plug and chug, right? Now I just plug and chug, right? But the question is here is I know what to put in for dx dt. I put in a 0.03, which is technically 3 over 100. So it makes the simplification really nice. Okay, but the question is, what do I put in for x? And this is where students really struggled with this back in the day. Well, if the height of the tree is 50, right, I would just go ahead and do a little side work and set that equal to 50. If I set that equal to 50 and just solve, right, I'm going to multiply that over. I get that. I get x equals Ichiban. So believe it or not, if I'm doing all of this for when the height of the tree is 50, that means the diameter of the tree is 1. And since I found a derivative, I can substitute everything in. So let's do it. That would be 1 plus 1. It would be 100 times 3 over 100, right? Minus 100 times 1 times 3 over 100 all over low, sorry about this, you guys, which would be 1 plus 1 squared. And believe it or not, if you do all of that work, spling, that'd be 2 times 3, which would be 6. Spling, 3 times 1 is 3. 2 squared is 4. I get 3/4 as my answer. Man, woo, that was tough because that was a related rate. That was quite the problem because not only was it a table, man, not only was it mean value theorem, right? Not only was it mean value theorem, average value, trapezoidal rule, related rates. What else was it? We had to do the derivative using the quotient rule. Man, there was a lot to take in on that problem. So you get that one right, you definitely deserve a 5 on that AP exam. Hopefully it was okay. I'm sure if you pause that one, you probably struggled with it, but that's why I help you work through it when we're done. Okay, here we go. 2017, we got another table. And part A, let me make sure I'm ready to go here. All right, let's get it. We're dealing with a tank that has a height of 10 feet. The area of a horizontal cross-section of the tank at height h feet is given by A of h is given by A, where A of h is measured in square feet. The function A is continuous, and it decreases as your feet or your h get bigger. Selected values of A to h are given in the table below. Use a left Riemann sum with 3 subintervals indicated by the data on the table to approximate the volume of the tank. Now remember, how do you find the volume of anything? The volume of anything, right, class, will be equal to the integral of the area of a cross-section. Boom, that right there. Now they're asking me for this one, right, is to do it from 0 to 10. But they're asking me to just do a left Riemann sum. We all know that this guy here means area. And it's question 1, so I will be able to use a calculator. But using LRAM, what's LRAM again? 3 subintervals, right? Here's my first subinterval from 0 to 2. It means it's going to have a rectangle that has a width of 2. So it's going to be 2 times. Now remember, if it's LRAM, you use the left side. So it would be A of 0. And A of 0 would be 50.3. Plus, let's go to the next one. It goes from 2 to 5. So that means that's going to have a width of 3. But if I go from 2 to 5, the LRAM would be times 14.4. That'd be the not the height of the rectangle, but the square feet for that particular region. And then the last one would be 5 to 10, so it'd be plus 5, and then you use the left side, which would be the 6.5. Now you're allowed to use a calculator on this one, so if you did it all correctly, you would get 176.3 cubic feet. Boom, that's it. Not bad, right? Not bad, but there's a lot to interpret on this thing, which I think a lot of students may struggle. Now, that one was worth 3 points. And part B, which you're going to have to use some information from part A, is does the approximation, does that answer in part A that we got to approximate, okay, the volume? Is it a over or a under estimate? Please explain. Now, it says earlier, or if you just look at these, the area in square feet decreases. And if I'm dealing with a decreasing function, remember, LRAM will always use the left side. And if LRAM always uses the left side, there's going to be an overestimate. So the AP would like to see, this is how it exactly reads on the AP. The approximation in part A is an overestimate because the left Riemann sum is used and A is decreasing. So a good answer, you just say it's decreasing because when using a left Riemann sum, using their verbiage right here for a decreasing function, it will always result in an overestimate. Okay? All right, that was worth one. You're 4 points in. Okay, let's go to part C. That wasn't too bad. The area in square feet of a horizontal cross section, right? Cross section and volume kind of go hand in hand. Okay, but they introduced this brand new function here, and it's okay because we can use a calculator, so maybe I should put that in Y1. Based on this model, find the volume of the tank. Well, what's volume? Volume is simply equal to the integral of the area of a cross section, which they give us right there. Sweetie sweet, right? That's all they do. And they say, okay, and all I got to do is find the volume of it. Now, I'm trying to see if I missed anything, but I didn't. I guess they should have told me the amount of feet that we're dealing with, and we're still from 0 to 10. So to get this answer, that is all you would have to do in your calculators. So what they cared about here is if you were able to interpret what they were asking for. And I got 101.325 cubic feet. Okay, that was worth 2 points right there if you were able to do that, right? And what would I have wanted you to do? Volume. How do you find the volume? Well, it's either discs, washers, or cross sections. And here they give you a cross section and they give you the area of one of the cross sections. So remember, it's just the integral of one of the areas of one of the cross sections. And they give it to us. Nice and easy, Japanesey. All right, part D gets a little bit tougher. Okay, water is pumped into the tank when the height of the water is 5 feet. So when H equals 5, remember I teach you guys to write stuff down. Okay, when H equals 5, the height of the water is increasing, dH dt. So when H is equal to 5, that's at the moment in question. It's increasing, so it's positive 0.26. Remember, if it was decreasing, it'd be negative. Using the model from part C, find the rate at which the volume of the water, whoa. So we're using the model from part C. What was the model from part C? That was the volume, okay? Depending on what your H is, which is feet, right, is equal to the integral from 0. Now I'm going to use a different variable because because they're asking me to find a rate, and the rate would mean derivative. So I'm just going to call that x, and then we'll use f of x dx because they're asking me to use the one from part C. Okay, but remember, we got to use different variables whenever we take the derivative. Could have used any variable you want. Okay, so using the model from part C, I got that. Find the rate of the volume. Well, the rate of the volume would mean the derivative. So that would mean I'd have to find dv dt. And it does say with respect to time. Okay, so how do I take the derivative of this side? Well, let's go. Ooh, my bad. This is the variable I changed. If that's h, it's still 0 to h, right, class? Hopefully you're like, come on, Mr. T. All right, so how do I take the derivative of an antiderivative? Well, we all know. We just substitute that guy in here, but something very interesting happens. It's going to become f of h. But what do I have to do? We always chain when we take the derivative of an antiderivative, and it usually is just 1. But this time, it's with respect to t or time. So my h, the derivative of h is 1, but since it is with respect to time, I got to slap on a dh dt, and that was the difficulty of this problem. So to get this answer, it is simply, I'm going to come down here, f of 5 because it says when h is equal to 5, and then dh dt is 0.26, right? What's f of 5? You can just plug it in right there. And if you do all that correct, you get an answer of 1.69441.9. And if you got that, you got the remaining 3 points. Obviously, 2 of the points were if you were able to find the derivative correctly. And boy, I think that would be tough. That definitely would be tough, right? I almost made a boo-boo with all these x's here. right? But if it's v of h, it's got to go from 0 to h. And then you got to remember when you take the derivative and you do the derivative of an antiderivative, you always have to be careful of the chain. And this time it chains implicitly. Why? Because it is with respect to time. Okay, here we go. Next problem. 2016. If you notice these tables, and I don't know about you, but these are some of the tougher ones we've been doing this year. All right, here we go. Another table, and boy, does this guy have a doozy on it, you guys, from 2016. Water is pumped into a tank at a rate of WT, liters per hour from 0 to 8. Right, it's measured in hours. Water is removed from the tank at a rate modeled by R of T, which is liters per hour, and the table is given below. And it says that R is differentiable and it is decreasing. Okay, selected values of R of T are shown in the table at time T equals 0. There are 50,000 liters of water in the tank. So that's like an initial condition. I bet you it comes up later. All right, part A. What's R prime of 2 and what the heck does it mean? Well, this is R, so R prime of 2. Where's 2? Ooh, it's between these two guys. So all I would have to do to find R prime of 2 is an average rate of change, right? That's a derivative, that's a slope, okay? And if I do that, what is it? It's going to be 950 minus 1190 all over 2. And if you do all that correctly, you get negative 120. And then let's look at this. The R, the top is liters per hour, and the bottom is hour. So it would be liters per hour per hour. And it says do the units of measure. So make sure you knew that it was liters per hour squared, or you could say liters per hour per hour. Kind of seems cool to do it. Liters per hour per hour. How fast can you say it? All right, what would that be worth? That would be worth 2 points. All right, part B. Use a left Riemann sum. We just got done doing this, right? 4 subintervals to estimate the total amount of water that would be removed. So we're trying to do an integral from 0 to 8 of a rate, right? If I do it of the rate, and it is a rate, sweet, that's going to give me the total amount, right? That right there, because it is the integral of a rate. It'll give me the total amount of liters. Sweet. Is it a over or under estimate? Okay, this is just LRAM. Well, LRAM, and it's done with 4 subintervals, so we're going to start here, 0 to 1. Okay, it has a width of 1, and the rectangle would just be the left one, so it'd be times 1340. Okay, plus the next one is from 1 to 3. 1 to 3 has a width of 2, and the height I'm going to use, right, is 1190 because I'm going to use LRAM. The next one would be 3 to 6 times 3, but use the left one. It would be 950. And then the last one would be 6 to 8, which would be 2. Use the left one, which would be 740. This is number 1, so you would get to use a calculator. And I got 8,050 liters. Okay, but then you have to explain. Now that gets you what? Points, but then now you have to explain whether or not this is a over or a underestimate. It is a decreasing function. It says it right there. And whenever it's a decreasing function, your left Riemann sum or LRAM will always give you a overestimate. Okay, and that would get you the 3rd point. So far you do parts A and B correct. That's 5 out of 5. You're well on your way to that 5 on the AP exam. All right, part C. It's got to get tougher than that, doesn't it? Use your answer from part B to estimate the total amount of water in the tank. Woo, total amount of water. Okay, so I got water being pumped in, I got water being removed, but most importantly, I got water that started it there. So the total amount of water would be 50,000 plus from 0 to 8, the amount of water that will be pumped in minus the amount of water that would be removed. Guess what? You already got that answer. Boom. Plug all of that in your calculator, right? That should go into Y1. This is just a math niners. And if you do all that correctly, you get an answer of 49,786 liters. Make sure you hit pause. Make sure you can plug that in your calculator. I should have said it earlier, but you guys just know by now, every single time we do a step, hit pause, challenge yourself, see if you can get it on your own. Now, part D, boy, did this cause so much trouble the year this was on an AP exam. This was tough. It says, is there a time T when the rate at which water being pumped into the tank is the same as the rate that the water is being. So we're both talking rates. So we want to know, is there ever a time when W of t equals R of t? How the heck do I find that out? Well, now I know how to do this one. So I know this is an IVT problem, but the only way W of t would equal R of t would be when W of t minus R of t would be equal to 0. KK, you buy it? Do you buy it? Well, you needed to buy it to be able to do this. All right, well, now these are continuous functions. Why? Because they're differentiable, right? If they're differentiable, they've got to be continuous. Well, that's first and foremost. Okay, next, I'm going to work with some endpoints here. I'm going to find, you just kind of have to explore a little bit here. W of 0 minus R of 0. What is W of 0 minus R of 0? Well, guess what? I'm just going to say, hey, that's greater than 0. Okay, and it is greater than 0, right? You plug that into your calculator, you compare it to 1340, and it's going to be greater than 0. And I'm just going to go with endpoints. W of 8 minus R of 8. Okay, R of 8 is 700. W of 8, just plug that in your calculator, but guess what? That answer was less than 0. Bingo, it worked. Right? If I'm dealing with continuous functions, as long as this is greater than 0 and this is less than 0, the IVT, the intermediate value theorem, everybody in between would be hit. And if everything in between would be hit, that means there would be somewhere between 0 and 8 where W of t minus R of t would be equal to 0, which would mean they would be equal to each other. Boy, that was a lot. That was a lot. It's only worth 2 points, but boy, if you were able to figure that out, huge kudos to you guys. All right, here we go. Let's go on. What are we on now? We're on 2015. Let me change my page over. All right, here we go. Last one in this unit. We're 2015. We're number 3. It's going to seem crazy, but this is a non-calculator question, and boy, do they make math. So I would practice it right now, okay, you guys. I'm not going to waste the time doing the busy work math with you guys, but you may want to do it. I use the table to estimate v prime of 16. Well, since this is v of t, v prime would be the derivative, which would be the slope, which would be an average rate of change. And I'm going to use between 20 and 12. So that's just v of 20 minus v of 12 all over 20 minus 12. And if you do that work correctly, you get 5. Now that would be meters per minute on top. So it'd be meters per minute. And on the bottom, I got minute. Did they ask me for units? They didn't, but that would be 5 meters per minute squared. Okay. Now you won't get penalized for putting minutes if you get a unit, if you get the units incorrect. But it's helpful to always put units just in case they ask for it. Okay, using the correct units, explain the meaning of this guy right here. We all hopefully know when we take the absolute value of velocity that that stands for total distance. I hope so. So hopefully you said using units, it's the total distance that over that 40-minute period that Johanna jogs. Okay, I'm going to read exactly what they have here. They say it's the total distance Johanna jogs in meters. Darn it, I forgot in meters. Okay, over the time interval from 0 to 40 minutes. Okay, and they did ask for using units, so I shouldn't have missed that. But they want to know that that if you take the integral of a rate, you get the total amount. So I get the total amount of meters. Okay, now they asked me to use a right. This is awesome because the first two we did today were LRAM. This is an RRAM, okay, for 4 subintervals, but they are asking me to find the total distance, and I see a negative in here, so that should be a little bit of a red flag. And the only red flag is I'm just going to turn the absolute value, right? I'm going to turn that guy positive. So here we go. What would this look like? Well, the integral from 0 to 40, and it's important to write that out, of v of t dt. Right? I'm not allowed to use a calculator. So my RRAM would be, that's a width of 12, but this time it's a height of 200. Okay, if I'm dealing with rectangles. And when I say height, that's what I mean. All right, plus 12 to 20 would be 8, right? And then it'd be 240. Ooh, not minus, I was subtracting. I just got to use the right side, 240. Okay, the next one only is a width of 4. And I got to use the right side, negative 220. No. Absolute value, total distance, that would be 220. And then my last one, whoa, that's a big width of 16, and it's 150. And yes, you would have to do all of that on your own. So it seems kind of crazy, right? They want me to do all that crazy busy work just to get that, but it would be worth 3 points, right? You get one for the explanation earlier about total distance. You get one for 7,600. Or no, you get one for showing you got the Riemann sums, and then one to see if you have good Algebra 1 skills. Okay, here we go. Part C. You guys are going to love Part C. Please, please pause it and see if you can get these 2 points on your own. All right, Bob is riding his bicycle along a path from 0 to 10. Bob's velocity is modeled by B of t, where it's measured in minutes. B of t is measured, I'm sorry, where t is measured in minutes, and B of t is a velocity. It's a rate, so it would be meters per minute. Find Bob's acceleration. Come on. Bob's acceleration would simply be b prime of t, right? Which would be 3t squared minus 12t. And they say to find it at t equals 5. So here's all my appropriate work. You plug in a 5, you do some algebra 1, and you get 15. Does it ask for units? It doesn't, but it would be meters, right, per minute, right, per minute, or per minute squared. Boom. They didn't ask for units, though. It was only worth 2 points. You got 1 point for the derivative and 1 point for getting 15. All right, that means the last piece is worth 3 based on Model B from Part C. Find Bob's average velocity, average value. Average velocity, average value. What does that mean? That means it is the integral of his velocity over the interval over the integral over the interval. And that's it. That's all you got to do. And guess, oh snap, maybe it's not that easy because this is not a calculator one. 10 on the bottom is nice and easy, but on the top, it's going to be t to the third minus, and this is the one that I should have said do it on your own also. But hopefully you guys have bought into what I've asked and you're trying these guys on your own. So on the top, they're just making you do some busy work, some antiderivatives, right? Antiderivative of t to the third would be t to the fourth over 4. Remember, this is all going to be over 10 at the end, your interval. A negative 6t squared would be negative 2t to the third, and then it would be plus 300. And you're going to evaluate that from 0 to 10. Please just make sure you plug in the 10 first, minus plugging in the 0. Okay, ooh, a t right there. All right, which would be minus 0. And if you do all that correctly, that busy work, you get 350. Just know that the top, right, if you do the integral of that rate, you're going to get meters. And then on the bottom, it's your interval, which was in minutes. And did they ask for it? They didn't. But you would get 1 point for the integral, 1 point for the antiderivative, and 1 point for your answer. And that would be the remaining 3. This video lesson is donezo. Hopefully you guys are doing these. Please pause them. Remember, you can always look up old tests and get better and better on your own. Alohas!